Hello scholars, it's Mr. Alan again, and I'm glad to host you in another lesson segment. And today we'll be looking at a very interesting topic I tag acids and bases. So I'll run you through various slides to explain what we mean by acids and bases. But many a times when people hear of acids and bases, what comes to mind is corrosion, what causes harm or disfigurement on some people's skin. But it goes far beyond that, as we'll be looking at it on a broader note. So our unit is acids and bases. So I'll be glad to walk you through this, and I hope you will enjoy the lesson. So let's see how it goes from here. Okay, we're looking at acids, bases and salts introduction, because it's a very important concept in nature, and you can find them all around us from the different food materials we eat. So in this lesson, I will put you through the basic concepts about acids and bases, and to let you know that we have corrosive acids like you usually think, and we also have useful acids we get from food materials. The wheel for today is your ability to identify and differentiate between acids and bases in materials around us. Okay, now a question goes, are you familiar with the term acids and bases? Before now, have you heard of acids and bases? Did you hear it from adults? Did you read it in a book or you saw it somewhere? Okay, acids and bases are part of your everyday lives. So in this picture you can see here we have acids. An example of acids, you find them in mostly grape or the orange family. They have what we call the citric acid. You have vinegar that we use to treat our food and also to prepare food also. Some people use it as a disinfectant to wash different food materials. Then we have bases here, and these are examples of bases. We have Schweppes here. Schweppes is a carbonated drink that consists of soda. Soda is the basic material used in producing these drinks, and some other materials we use like our washing, liquid soaps, and bar soaps, and so on. Okay, we're going to see more on acids and bases. So basically, acids and bases are substances that contains what we call the hydrogen ion and the hydroxyl ion. So acids are characterized by the presence of hydrogen ion, which we tag H+. It is called hydrogen ion, while bases are characterized by the presence of hydroxyl ion, that is OH-. Now these are the main elements found in these substances that gives them their characteristic name acids and bases. So for an acid, like I said earlier, you will always find the presence of hydrogen ion. These are the charges that makes it have its acidic characteristic, while the hydroxyl ion OH- is what gives bases their characteristics. Okay, so let's talk about the sources of acids. Acids are gotten from different sources. We have vinegar. Vinegar consists of acetic acid we use in our kitchen and in most food processing industries. We also have acids found in an apple. Apple is a fruit. When we eat apple, it gives us what we call malic acid, and malic acid gives the body vitamins for strong immune system. So that's another importance of acid there. Then we have ants. Now when ants sting someone, there's this feeling of pain, very stinging pain, as a result of the formic acid in the abdomen of the ant. So when ants stings or bites, they release what we call formic acid into that spot. They beat you and you feel pain as a means for them to run away from probably their predators and to stay alive. It's a defensive mechanism. Okay, so also we have milk. Milk consists of what we call the lactic acid, and this what gives the body proteins in form of amino acids for body building and development. So as you can see, acid is not in all sense bad as people used to think. There are good acids and there are bad or corrosive acids. Then we have grapes. Grapes are common fruits. It consists of what we call tartaric acids. These are acids that helps to also add to the vitamin level of our body so that our body's immune system can stay strong. Then tomato, a common fruit or vegetable used in making our sauce, consists of what we call the oxalic acid. So this oxalic acid supplies some vitamins, supplies also some minerals that helps the body's bones and development to be strong. So these are different sources of acid. We have so many other sources of acids in the environment, but generally the orange family will give you the citric acid. Like in this case we have lemon, As you can see, it gives us citric acids, the normal orange, the tangerine, the bitter orange, and so on will give you citric acid. So away from the sources of acid, let's talk about the properties or the characteristics of acids and bases. What gives them their characteristics? So acids will turn blue litmus paper red. There's what we call the blue litmus paper. They are test papers that helps to test for the presence of acids and bases in any substance, be it a food material or maybe a liquid substance or a chemical. If we want to know if it's acidic or basic or alkaline in nature, we use what we call the litmus paper. So the blue litmus paper will turn red when you dip it in any acidic material. And when you test acids, they test very sour. Then acids corrode metals. When they come in contact with metals, they corrode, it causes corrosion. Positively charged hydrogen ions is what makes them up, like I said in the earlier slide. Then bases turn red litmus paper blue. When you dip a red litmus paper into them, they will turn blue. Then they taste bitter to taste. They are negatively charged hydroxide ions, OH-, they feel slippery to the touch. When you use soap to wash or detergent, you feel the slippery nature in the water. Then most hand soaps and drain cleaners are bases, and they are strong bases made of caustic soda. Soda is sodium. So sodium is a basic material, it's alkaline or slimy in nature. So this is an example of the litmus paper I talked about in the previous slide. Now, if you dip red litmus paper into a base, it will turn it into blue color, as you can see here. Then if you dip a blue litmus paper into an acid, it will turn it into red. So that's just an indication of the presence of acids in different materials. Okay, so this further gives us what we call the characteristics of acids. They taste sour for acids, they feel sticky, and they contain citric acid like soda. Then here for bases, they taste bitter to the taste, they feel slippery also to the touch. And you know, when you check the egg white material, it feels slippery when you touch it. Then we'll talk about pH. pH means the hydrogen ion concentration in acids and bases. So the neutral acid or hydrogen ion concentration in any of these substances is always at 7. So we have pH of 7, meaning that they are neutral. But on the pH scale, which I will treat later, you'll see it as a scale of 1 to 14. From 1 to 6 is acidic, 7 is neutral, then from 8 to 14 on the scale is alkaline or basic in nature. So there's a reaction we call neutralization reaction when you mix acid and base together in a container during an experiment. The product is going to be salt and water. We call it neutralization reaction. So when acid and bases react, they will produce salt and water. For instance, if you have maybe some juice from orange poured into maybe detergent, there will be a ladder formation, and when you check the product, it will give you what we call a salt and water. So you can experiment using different acid and different bases from different materials in the environment, but always play safe and exercise caution. Okay, so I just explained the neutralization reaction. When you mix an acid and a base, it gives you salt and water, as you can see here, and so many examples we can take from the environment. So this is an example of an acid. We have hydrochloric acid here, and we have sodium hydroxide. It's an example of a base. Then sodium and chlorine, when you have them in a container mixed together, it forms a solution of salt. So when you add acids and base, you get salt as the result. Okay, these are general characteristics of acids and bases. You can go through this at your leisure time. You can play and pause this video to do that. Okay, this is an example of what we call the pH scale. Like I said earlier, the pH scale is a scale that helps us to measure the presence of acids and bases in a solution. On a pH scale, we have the scale ranging from 0 to 14. In my early explanation, I said from 0 to 6, any food material that falls within that category is acidic in nature. That means it contains acid. And any materials that fall within the 7, which is neutral, it means that it doesn't have acid or basic concentration in it. It is free from their presence. Then we have from 8 to 14 on the scale is alkaline. So if you look at this example, you have a stomach acid, which is hydrochloric acid. It is between 1 on the scale. Lemon is 2 on the scale. Grapes 3. So if you follow through, you'll be able to fix examples of different materials based on their level of acidity and alkalinity or basicity. Look at the picture here, it gives you a lot of examples you can take home. Okay, so this is the pH scale. It's more explanatory here. As you can see, from 0 to 6 is acidic. The 7 mark is neutral. Any substance that falls here is neutral, which means it doesn't have acid or base in it. Then from 8 to 14 is alkaline or basic in nature. An example of a neutral substance is water. Water that is not polluted, like the drinking water that is processed in industries into our bottled water or sachet water, is meant to fall as 7, which is neutral. Anything that goes beyond 7 or below 7 means it has impurities and it's either acidic or basic. So that's how it is applied in real life situation. Okay, I'll summarize this lesson. Hydrogen ion concentration is what makes acids what they are. Then hydroxyl ion concentration is what makes bases or alkaline materials what they are. And the symbol for a hydrogen ion concentration is H+ for acids, then it is OH- for bases. Then when you mix acid and bases together, it will produce salt and water in a reaction called neutralization reaction. So we looked at different substances that contains acids and bases, like the grape, like ants, formic acids, and other food materials we eat. They produce different forms of bases and acids for use. So I want you to explore more, and if you have any query or any question about this topic, you can put your comment on the Google Classroom. So I'll see you in my next segment. Bye for now from Zoologist Alan.